Hey everyone, welcome back. In the previous lessons, we were talking about document changes, and in this lesson, we are going to talk about queries and ordering, okay? So go ahead and open up your browser and go to your Firestore database. And in the prior lessons, we talked about how the default order for a query is the alphabetical order of the document IDs here. Now that's almost never going to be how you actually want your data returned. You will most likely want to return the documents in a certain order and or a subset of that data based on certain criteria. This is done in Firestore using queries. So let's go ahead and open up a new tab and just search for Firestore Query iOS. And we're going to take a look at this one right here, perform simple and compound queries in Cloud Firestore. All right, and make sure that your tab here is set to Swift. And up here it says that Cloud Firestore provides powerful query functionality for specifying which documents you want to retrieve from a collection. These queries can also be used with either get or add snapshot listener as described in yada yada yada. All right, so starts out here and it tells you how you can add some test data to your Firestore database. We already have some documents here. We have our categories. And then we start out with simple queries, okay? So here we have a reference, just like we have in our code. Let me jump back here. So we have our collection reference. And then to add a query, it's as simple as saying .where field, and then you specify the field that you want to query on, and then a type of query. Okay, so in the case here where we have a number of cities, this query is going to go and return any city documents where the state field, so right here, let's see here, right here, is equal to CA or California. Okay, so that will return, it looks like 2 of these documents. Los Angeles and San Francisco, since those 2 documents satisfy the criteria provided in this query, which is that the state field's value is equal to CA. In this example, we have a query where we are querying on the field capital and whether or not it is equal to true. So in this case, we have a number of fields with capital and whether it is true or false. Looks like it's going to return these 3 documents since the capital is true for these 3 documents. And right here it says that the where method takes 3 parameters, a field to filter on, a comparison operation, and a value. Okay, so the comparison can be less than or equal, greater than or equal to, or array contains. And this is new. This is super useful actually, and we're going to be using this when we get into the favorites part of our app. So it's pretty straightforward, super simple. And what I want to do is just kind of do a few queries in our app just to kind of get a hang of it. Another thing that is important is compound queries. So we can chain multiple where methods to create more specific queries. So it's a logical and. But there are some caveats here. It says, however, to combine the equality operator with a range or array contains clause, make sure to create a composite index. And we're going to talk about composite index here in the future when we get into the products. And then it shows a couple of things some limitations here. So what you can do is have range filters on only one field. You can't do range filters on different fields. And then finally, there are some limitations to Firestore queries. So these are the types of queries that are not supported. Queries with range filters on different fields, single queries across multiple collections or sub-collections. Each query runs against a single collection of documents. All right, and this is probably the biggest limitation that you'll run into. This means that, say you have 2 documents in the same collection. Each of those documents has a sub-collection. There's no way to run a query against both of those collections. And so that's something that you need to think about from the get-go, how you are going to architect your data. You also can't do OR queries, so that's kind of a pain as well. It says that in this case, you should create a separate query for each OR condition and then merge the query results in your app. So you would need to do 2 queries and then add those results. And then you also cannot do a query with a not equal clause. So going back to this limitation here, where single queries across multiple collections or sub-collections is not allowed, we'll often want to have our documents be in a root collection. And so you may think, well, if you have a root collection that has a whole ton of documents, isn't that kind of going to slow things down? And the answer is actually no. The way that Firestore implements its querying is pretty impressive. If you have a collection of categories that has 10 total and you're querying for 5 of them, you may think that that will return the results much quicker than if you have a collection of 1 million categories and you're only querying for 5 categories. They are actually going to query at the same speed thanks to the way that Firestore is architected. So that's pretty cool. So let's see some queries in action. Let's jump back into Xcode. And here we are in our home VC, and we have our categories reference right here. Now, instead of having the .add snapshot listener right here, we're going to introduce a query. So we're going to say .where, and then you can see here all of our options. Where field is equal to, is less than, array contains, is greater than, is less than or equal to, is greater than or equal to. Those are our options. So let's go ahead and do some tests here. We can do a query on our data. And let's just go ahead and grab one of these. Let's do a query on our collection where the name is equal to landscapes, okay? So back into Xcode, we can say where field is equal to name and the value is equal to landscapes. And then get rid of that space, bring that back together. So all we're doing here is we are just introducing a query to only return documents where the field name, its value is equal to landscapes. So how many categories should we now see? If you said 1, then you are correct. Let's go ahead and see if this works. Hey, there we go. So we have successfully queried for our criteria of the name being equal to landscapes, and we are seeing just one here. All right, let's do another one. Let's go ahead and say maybe, let's see here, what else could we query on? We could query on where is active. Let's go ahead and change one of these to false. Update that. And so we have 1 where the isActive is false and 2 where it is true. So back into Xcode, we can say where field is active is equal to, and we can say true. Save that and run it. And now we should expect to see 2 categories. Oh, there we go. All right, so now we have our 2 categories that have the isActive set to true. All right, so what I want you to do is to go through the rest of these different types of queries and play with them and see if you can get different results coming back from your categories collection. All right, so hope you played a little bit with these different types of queries. Next up, we are going to talk about how to order data, okay? So when you're querying, you're still going to be returned in the order that we see here, this alphabetical order. It will just be a subset of this data. To order it, we need to, let's click on here, order and limit data. This is also very simple and intuitive. We have our ref, and then we just tag on a .order by, and then we tell it what field we want it to order by, okay? So coming back into our database, let's say we want to order by our timestamp. All we need to do is back into Xcode. So instead of this query, well, to show you that we can add multiple queries and ordering, we can say .order by, and then you'll see here that we have field path, and then we also have descending, okay? So here is just going to return it automatically. And then here we can say descending is true or false, and that will change the order in which the data is returned, from top down or bottom up. All right, so let's go ahead and say order by, and we're going to order by the time stamp, and then say dot add snapshot listener, save that and run it. And let's see here, let's open this up, and you'll see that it doesn't look like it worked. And that's because if we look here in our console, it says this query requires an index. You can create it here, okay? So looks like we're getting into our composite index earlier than I thought, but this requires a composite index. So you can do this manually in your console, but it's really nice when Firestore, it recognizes that we need a index here. And so it automatically gives us this URL that we can just copy and paste into our browser. And what it's going to do is it's going to take, and it knows the information that it needs to create the composite index, and it's going to do that for us right here. It says composite indexes are required for queries that include specific values and a range or order. And so it shows that the collections that we need is in categories, and that the fields is, we're testing is active, ascending, and then timestamp ascending, and then we can say create this index. And so you'll say create index, and it'll go through and build out that composite index for us. And once it's done, then this will work. Now I'm actually going to go ahead and remove the .where field is, because this actually isn't a query that we are going to be running right now. So I'm going to go ahead and get rid of that, and we are just going to be ordering by timestamp. So I'm going to save that, and then I'm also going to come back to our database and change that one that we set false back to true and say update. All right, so now these are all is active true, and let's take a look at our timestamps. We have a March 5. All right, so these are all, we have a March 2 right here. Let's go ahead and change this top one to today's date, which for me is the 12th, and say update. All right, so now we have 3 different categories with different timestamps, okay? So let's see which order this should be in. We should see portraits first, then cityscapes, then landscapes. Let's see that. All right, so I'm gonna go back into Xcode and run this. And there we go, portraits, cityscapes, landscapes. Is that the order we expected? Coming back to Safari, we have portraits, cityscapes, then landscapes. Okay, so right now, the order is possibly backwards from what you might expect. So right now, the latest entry, March 12th today, is the last one displayed here. So what we can do is we can change the order here. So remember we had .order by, and then we have string and descending. So if we say order by, and we say time stamp, and then descending, if we say true here, then the latest category added will be first. So I'm going to say save and run. So now we should expect to see that order reversed. There we go. So now we have landscapes first, then cityscapes, then portraits. So now I'm going to move this over here. And remember last lesson, we talked about how we weren't able to check the modified document case where the item changed and changed position because we didn't have the ordering in yet. Well, now we do have the ordering, so let's test this. So I'm gonna open up our simulator and our browser, and we are going to change the order of one of these documents, okay? So let's take, let's say portraits, and let's move it up to the slot number 2, which means that our portraits needs to be earlier than, let's see here, March 5th. So let's set the portraits to March 6th. And what we should expect to see is that portraits will move up into the number 2 slot and cityscapes will move down. All right, so I'm going to press update and there we go. Awesome. So our on document modified for the case where the new index does not equal the old index is working perfectly. All right, and there you have it. Querying and ordering is pretty simple and straightforward. For queries, you simply say .where on your document or your collection or document reference. You provide a field to filter on, a comparison operation, and a value. And then for ordering, you simply say .order by and then provide the field that you want to order by. And then you can also limit it. So for instance, if you only want to receive the first 3, then you could say .limit to 3. And then down here, so this would be, you could also sort in descending order to get the last 3 cities, .limit to 3. And then same thing with queries, you can also order by multiple fields, but there are some limitations to that as well. If you have a filter with a range comparison, your first ordering must be on the same field, okay? So this is a valid example where the range filter and order by are on the same field. So .where field, population, .order by population. So that's okay. This is not okay. You can't say .where field, population, and then try to order by a different field. So those are just some other limitations for Firestore ordering. All right, but yeah, go ahead and play with this a little bit. Try doing different queries, different orderings, see what happens when you change the descending from true to false, give the .limit a try, and let me know what you come up with. Let me know if you have any questions, and I will see you in the next one.